Thank you again for joining me. Before we start, I would like to share a personal experience that showed me how challenging and difficult it can be to handle a ransomware. Back in 2014, one morning I walked into my office starting to plan out my day. Around 9:30, I got a mail from one of my big healthcare customer saying that some of their backend systems on which my team conducted pen test in past couple of weeks have stopped responding, and they thought that my team actually broke those systems. Now, it was a little bit concerning for me because we did not use any of those intrusive tests. So could it be that someone else figured out what was out there on the network and exploited that? To refresh my memory, I started reviewing the report. There were systems that were unpatched for months. They had a yearly patching cycle. The entire network was flat. Some of their critical systems were running outdated Windows. It was basically a pen tester stream. So armed with that knowledge, I met with a customer around 10:30, 11 a.m. to start figuring out a plan for isolation. Well, within a couple of hours of network traffic analysis, we isolated the problem or the cause of the problem to a bunch of systems that have had a surge of network anomalous traffic over past couple of weeks. Now, many of these systems belonged to executives. So, as you can imagine, this issue was political now. Regardless, we decided to call those systems in to perform a deep forensic analysis. And while we were in the midst of it, around 1 p.m. or 1:30 p.m. that day, we got a call from one of their large health hospitals saying their patient intake systems are down, and was showing the same error message, the banner, that the backend systems were showing in the morning. And so their patient intakes, the whole process has now gone manual, which was a big issue because not only the process was inefficient, but also error prone. So needless to say, the focus shifted to get that process ready, to get those systems up. And while we were in the midst of it, around 4 p.m. or so, the same health hospital reported that the systems that manage their operation theater network, that was down as well. Same issue. But now, as you can imagine, from between 8:30 a.m. that morning to 6 p.m. that afternoon, the threat has gone from the corporate data center all the way into the back ends of a hospital. So it has graduated. So regardless, we started focusing on getting this particular health system up, this hospital back into operation. But by 6:37 p.m. that night, we started getting calls from other hospitals as well that they are seeing the same issues. So now you can see that this threat has migrated from the corporate data center to their entire healthcare network and was causing the major pain. Now I hope some of you can relate to it. And this story does have a happy ending, and no, they did not pay the ransom, and I will talk to you about it. But as you can see, this was a very challenging threat to handle. My name is Abhi, and in the next 30 minutes or so, I'm going to show you how you can become proactive so this doesn't happen to you. We will talk about how ransomware has evolved from just being a minor annoyance into becoming a major extortion issue. We will talk about some of the frameworks that are out there that you can use to come up with your own strategy. We will also talk about how that framework would look like on AWS, so potential architecture. Then we will spend a considerable amount of time, like I said, on making you proactive, giving you the tools that you can use proactively handle this threat. So that being said, let's talk about how this threat has evolved and where it's heading. So ransomware gained notoriety around early 2000s, but back then the threat was local. It used to affect couple of well-known files. So your Word files, your PDF files, your zip files. And if you were to get infected, the ransom was a couple of $100. If you were unlucky enough, you would pay with a gift card. And attackers used to use tactics like your fake antivirus to infect you. Most cases, your antivirus software was able to detect it and was able to neutralize the threat. But a big change happened around 2013. This is a time when ransomware started getting featured in the national news cycles. For those of you who remember, CryptoLocker was one of them. This is when the attackers moved away and from the fake antivirus banners to now they are using the impersonation and scare tactics. And instead of going after some files on your network, on your systems, they started making your entire system servers unusable by encrypting the master boot record. And if you don't pay up, they would delete your data. But the scariest era started, in my opinion, around 2016. This is when the organized crime realized the potential of ransomware and stepped into it. Now, instead of going after a couple of servers, they started going after entire server farms, your IoT farms, your SAN devices. And instead of just simply deleting your files, attackers would now extort you for money. They would expose the data. Another big change that happened, which I believe is going to be in the future, which is going to decide the future as well, is the advent of ransomware as a service, the democratization of this thing, so that you don't need to have super skills. You can buy this thing on the dark web. So much so that now they're not blindly going after your assets. They know what they are very focused on the type of data they are going after. They're going after the financial documents, your tax data, your PIIs, and things that will hurt you the most. The threat has become so pervasive and so important that FBI is now involved in it. In 2019 alone, FBI got over 2,000 complaints and a reported loss of over $8.9 million. I read somewhere that crypto wall alone generated roughly around 20 to a couple of $100 million in revenue. So now the point and shoot approach that we have been used to in managing this threat is not going to be good enough. So we have to think about a very, very well thought out, structured approach to handle ransomware. So if you think about it, what have we learned? None of these things should be a news to anyone. Now, the earlier we detect, the smaller the impact. We need to use threat intelligence, we need to use threat hunting to detect or to separate a smash and grab attack from a dedicated attacker. We need to segregate our networks, deploy least privilege, apply protection across all layers. We need to patch our systems. And if you are using features like auto scaling and launch templates, hopefully you are treating your servers like cattle rather than treating them like pets. And then go ahead and automate as much of it as you can so that eventually you can move over to a complete infrastructure as a code environment, especially in your production workloads. And then don't forget that users are a key part of the solution. So training the users is very, very important. All of these things are easier said than done. This can be expensive and time consuming. So when I ask this question to my customer that how do you know proactively that you are prepared to handle ransomware, I often hear 9 times out of 10 that this is too expensive. They are busy fighting fires. They do not know how to prevent or how to mitigate the threat. Even if they can detect it, they don't know how to go about it. To solve for this strategic gap, NIST, which is a US federal agency that creates the standards for US federal agencies and for critical sector companies, came up with a ransomware framework that describes 9 core capabilities that you can use to come up with your own defensive strategy. So let's talk about those. Inventory management talks about keeping a track of the CIs that exist in your environment. On cloud, this is especially challenging or can be challenging because those CIs, the configuration items, are dynamic. A really helpful service here would be AWS config. Vulnerability management then talks about knowing the weaknesses that exist in your account and across your entire organization. This includes things like open CVEs on your AMIs as well as weak configurations, such as publicly exposed lambdas and very permissive security groups. A very useful service here would be AWS Inspector and Guard Duty and Security Hub as well. Policy enforcement then takes the data from inventory management and vulnerability management and sets the right set of protections on those assets. An example here would be lambdas that can remediate an overly permissive security group or a publicly exposed lambda attaching it to a VPC. Policy enforcement also deals with setting up the right set of protections or guardrails from your organization level. So things like AWS control tower, SCPs using AWS organizations, and IAM permission boundaries will help you set the right set of governance from the get-go. In integrity monitoring then talks about understanding what is in your environment and what it looks like, so the baselining of it. a very good service here that will be of use is SSM, Systems Manager. Logging and monitoring then talks about capturing the events that happen on your environment and then forwarding it over to a central account for safekeeping, and then only allowing break glass access to that account. On AWS, some of the commonly used services here would be AWS CloudTrail for API level logging, CloudWatch for system and application logging, and VPC flow logs for network level logging. If you were to use Control Tower, like I mentioned before, CloudTrail and that centralized logging account with the right set of privileges would automatically be created for you as a part of Control Tower deployment. Backups are a central part of your recovery strategy. You can use AWS Backup to schedule periodic backups for commonly used data stores such as EBS, RDS, and DynamoDB. Secure storage then refers to protecting the malicious alteration of your data. Glacier vault logs, S3 object logs, separating the data volume and the root volume, and then mounting the root data volume as read-only to your EC2s can help you achieve that on AWS. Network protection talks about restricting the intruder's capability to intrude your network and then perform a lateral expansion in your network. On AWS, some of the services that can help you achieve that are security groups, network ACLs, guard duty, because it can detect malicious activities on your VPCs, and it can help you achieve network protection. And lastly, block listing, the C2 communications. On AWS, you can use WAF to block list the inbound communications. For outbound communications, you can use guard duty in conjunction with Event Bridge. You can also use S3 outbound security groups and our newly released AWS Network Firewall to achieve that. So how does it look like on AWS? This is a potential architecture. Now, as you can see, that guard duty and Event Bridge form the core of it. Event Bridge specifically, in our case, is the brain. This is where we teach the patterns, like when you find an EC2 instance based on the guard duty finding that is communicating with a known C2 server, go ahead and quarantine that instance, attach a forensic volume to it, take a snapshot of it, and then move the forensic analysis and the snapshots over to a specific forensic account. All of this can be easily done. You can perform almost real-time response using SSM playbooks, Lambda, and Systems Manager. And SNS. Then you have services that will allow you to do secure storage and inventory management, like we talked before. One of the most important takeaways that I want you to have from this particular slide is, without proper governance, none of this would be possible. So the Control Tower guardrails and organization-driven SCP, service control policies, should be at the forefront of it. But even if you do all of that, and if I were to ask you, how do you know that you are proactively prepared? How do you know you are following the best practices? Well, to make the answer easier, we created AWS Self-Assessment Toolkit. We used well-known frameworks like Scout Suite and Prowler as a part of the toolkit. Then we extended the checks by adding our own. We know the cost is a major factor for many of you. So running the SAT should not cost you more than a couple of dollars, and in many cases less than $1. We know that builders like to extend things, so we released the entire code on GitHub. But then more importantly, we know that not all builders are developers, and that should not come in the way from them protecting their accounts and their companies. So in order to run SAT, you do not need to have any programming experience or CloudFormation experience for whatever reasons. It's very easy deployment, and I will demonstrate that to you in just a minute. Then I was talking about adding our own checks. Remember, we were talking about the NIST framework a couple of slides ago, and then we saw how you can implement that framework on AWS using that reference architecture. Here, we know that SSM or Systems Manager should be a part of your defense strategy. So we added a check for that. We know that ransomware comes after outdated operating system. So we added a check for that as well. So we added many checks, and there are many checks that are coming as forward as well. So let's talk about what it looks like. Let me show you how easy it is to deploy. So we don't want to impact your existing workloads. So in order to solve for that, we create our own VPC. When you deploy SAT, we create our own VPC with a public and a private subnet. We then deploy a bunch of lambdas and an EC2 system that performs these assessments. And when you delete the stack, all of the resources get deleted other than that S3 bucket because it contains the reports. So pictorially, this is how it looks like. You have a VPC that has an internet gateway attached to it, and then you have all of these public and private subnets, and then when you delete the stack, everything gets deleted other than that one S3 bucket because it contains your report. So let's look at the deployment to see how easy it is to deploy SAT. So here, this is the public repo where we have SAT deployed. Sorry, where we have published SAT. That page that you saw has detailed instructions of how you deploy it, what it achieves, things to consider. And as you can imagine, there is no code here that you need to use to deploy this solution. Now you can download the SAT by cloning the repo, or you can download it as a zip. Here I have downloaded the zip the files. I cloned the repo. And I will upload the files over to this S3 bucket. Now, as the time of this recording, I have already deleted this account, so these resources don't exist anymore. So I'm going to upload all of these files onto that S3 bucket. And as you can imagine, no code to run this thing. Alright, the main file here that we are going to concentrate on is the first one, the self-service-sec.yaml. And again, it's not necessary for you to understand what's written in there. That one file is the main orchestration file that creates the resources that are needed for this check. So now we copied the URL for that file, and we're going to use that URL to create this CloudFormation stack. We're going to give the stack a friendly name, and we're going to select yes, we want to do the ransomware checks as well. And then we are going to give the name of the S3 buckets where we have uploaded the files that we downloaded from the GitHub repo. Alright, so far so good. Pretty simple. Again, important to note, there is no code required. We're going to leave the defaults as is, and we're going to accept the IAM capabilities because we are going to create resources that will perform some actions in your account. So we're going to accept these, and then the resource creation starts. Now, as you can see, it's creating a bunch of different stacks, bunch of different sources like EC2, IAM. So let me show you what the file looks like. So if you go in the file, you will see that we are going to create there is an IAM stack, VPC stack, sorry. There is an IAM stack, there is an EC2 stack, and all of these are creating the resources that are needed for for running the SAT. And then the ransomware stack as well. This is where there are a bunch of Lambda functions that are going to run the SAT ransomware checks. Right. Once the stack is deployed, you will get that S3 bucket. As you can see, I'm showing the S3 bucket was created as a part of the stack. And if you look for the bucket, you will see that there are bunch of ransomware checks, the results of ransomware checks already available for you. Each of these are object files. So one of the issues that you saw was that guard duty was not enabled in US West 1. And if you open that file, it's a simple text file, so you can open it in any text editor. I'm using Mac, so I'm using TextEdit. This file, the file will show you which regions this check has failed. So now you can see that it's failed in EU North 1, US East, US West 1, and US West 2. So Oregon and Northern California. Right, again, you achieved all of this without knowing even a single line of code. This is an EC2 instance on which we are through which we are running the Scout Suite and Prowler checks. And as you can see, in after around like 30 to 45 minutes, you will see the reports from Scout Suite and Prowler there, and we will show you the Scout Suite report. Now the question that we asked early on is you don't know what to go and mitigate. So here Scout Suite gives you a service by service breakdown of what has failed, of what issues exist, what weaknesses exist in that service. So here in case of EC2, we see that there are unencrypted EBS volumes and there are secrets available. So it's showing you where is that issue, in which EC2 instance, and where in user data. So you can go and remediate that user data, remove the secret from there. And then we will show you the unencrypted volume as well. So it's going to give you the volume ID that is unencrypted, so you can go and encrypt the volume. So we have reduced the burden on detecting what can be used to attack, and we also help you understand what or how you can protect yourself against those weaknesses. So now if you delete the stack, as I mentioned before, all the resources other than that S3 bucket will be deleted. So you will see that EC2 instance will be terminated at this point. As you can see, it's been terminated now. All right, so what if I were to tell you that there is more to it? There is more. You can extend this solution. You can extend SAT to perform automated remediation as well. So here, for example, I have written Lambda functions for each of the checks that perform the remediation. Then I wrote an step function, which in my opinion is such an amazing service. You get 4,000 transitions for free, and then for 3 cents more, you get another 1,000. You can write a lot of security orchestrations just with step functions for really cheap. All right, so all those Lambda functions that perform the remediation are being orchestrated with the help of this step function. And I expose this step functions API via API gateway. So the whole flow looks like this. When the checks complete, the admin gets an email that, hey, look, the assessment has been completed. Do you want to automatically start the remediation? If the admin so chooses, clicks the link that starts the workflow, and step function start orchestrating those Lambda mitigation functions. And once all of those checks have been remediated, then the admins again get a notification through SNS saying that, hey, we have remediated those issues that were found as a part of the SAT ransomware checks. So let me show you how this looks like. So here, as you remember, guard duty was one of the findings. So guard duty is not enabled in Oregon. And so we got it, once the checks were done, we got an email that, hey, it's been completed. Do you want to start remediation? And that's the API gateway link. By the way, again, like I mentioned before, this account is deleted, so these resources don't exist anymore. So once you click on that, the remediation starts, and you will see that guard duty will become enabled almost instantaneously. So there you go. So the guard duty is now enabled almost instantaneously. So how does this work? So as you can see, we're going to step into let me show you the step functions. So if you go in the step functions, Pretty simple step function. The middle part, which is the fat part, is actually where the remediations are happening. So the code looks like somewhat like this. So we check what has failed. Then based on what has failed, we have remediations that are orchestrated, and those one or more of those are run in parallel. And then ultimately we send a report to the admin that look, it's been remediated. So this is what the code looks like. So the step one is that checking what has failed, and the heavy lifting is done by this lambda that I'm highlighting. It parses through the results and sees what has failed, and then sends that data over to the next state. In this state, the data is now matched against which check has failed, so that corresponding remediation lambda can be activated. So in this case, our guard duty check has failed, so the guard duty lambda is now going to get activated. That's the lambda I'm showing on the screen. That's the part that actually does the remediation. And then ultimately, the admins get a note from the SNS saying that remediation has happened. That's the lambda that actually performs the notification function. Let me show you what lambda looks like. Pretty simple lambda. All it does is SNS publish with the checks that have been remediated. Right. Again, this is for the folks who want to extend the solution for performing the automated remediation. In order to run SAT, you don't need any coding. So here, once the checks are remediated, the admins get an email that look, remediation has been completed. All right, but I don't want to leave you with the thought that SAT is the only tool in your arsenal to protect against ransomware. SAT is point in time, but then you have Security Hub. Security Hub is such an amazing service. It's so easy to deploy, and once you deploy it, it continuously gives you an assessment of the security and compliance state of your account. And it integrates with AWS organizations as well. So it scales with you. It natively integrates with other AWS security services and with many of the partner products that you might already be using. So highly encourage you to look at the Security Hub as one of the core pieces of your defensive strategy. Now, many of you are storing the logs on S3 like CloudTrail. You can use Athena to predefine the queries that your SOC analyst might use. So for example, access keys that are creating most errors, or why is root being used, or who is trying to access the backups. You can pre-write those queries in Athena for your analyst. Now we know that in the future and the current phase of ransomware, attackers are going after your critical data. You can use Macy to identify where that data lives in your S3 ecosystem and then put right set of protections. CloudWatch anomaly detection is another service that might get overlooked, but such an amazing feature. You can write anomaly detection on user errors and application errors to raise alarms on things that breach a threshold. And then again, I talked about the step functions to orchestrate a lot of your security playbooks. Now, I know that many of you might not have a SIM. So you can use Elasticsearch, and you can send the data over to Elasticsearch and then use Elasticsearch outlier detection feature to detect anomalies. There is a very good blog post by Elasticsearch. I highly recommend you looking at the blog post on how to achieve that. Now, at AWS, we are constantly innovating on your behalf. We are happiest when our innovations vanish into your day-to-day. So I encourage you to take what you have learned today, help us spread the message, discuss about these tools and these learnings and these frameworks with your colleagues. Give SAT a go. Give us your feedback. Give us your feature requests via GitHub. And we are more than happy to work on those and make it better. Want to share the team that brought you this solution. Combined, we have several years of experience in cybersecurity, and we are constantly working with you to make things more secure for you. Thank you again for your time. I hope you all learned something from the session, and don't forget to give me your feedback. Thanks again.
Databricks is the data and AI company. We help data teams solve the world's toughest problems. The only open, unified platform for data management, business analytics, and machine learning.
You've heard it before. We're connected all the time. It's a digital world. At CrowdStrike, we keep it safe. So wherever you go, go with confidence. Welcome to Anywhere. CrowdStrike. We stop breaches.